In this video, we're going to talk about how to use proportions to solve problems. But before we do that, let's just remember what a proportion is. When we're using special math terms like ratios, like proportions, like area, like volume, like perimeter, we really want to know the meanings of those things so that we can understand them well. So what is a proportion? A proportion is a statement that two ratios are equal. In the previous video, we talked about what is a ratio. So clearly proportions are made out of ratios. So let's just remind ourselves too then, what is a ratio? Because if a proportion is made out of ratios and I'm not familiar with what a ratio is, I'm still no further ahead. A ratio is a comparison of two or more things. Let me give you some examples. A ratio could be 1 compared to 6. Another way to write that would be 1 compared to 6. Another way to write that would be 1 compared to 6. Looks like a fraction, but ratios can also appear in this form. Very different meaning than a fraction. Talked about that in the last video. Proportions then are built out of two ratios that are equal. So we could end up with a situation like where a ratio of 1 compared to 2 would be an equivalent ratio to 2 compared to 4. That's a proportion. Two ratios that are equal. Ratio number 1, ratio number 2, they're equal. All right, so in the last video, we looked at this example of making a proportional change to an image. And we did that by stretching the image, and we found out the new dimensions. If we started with an image that was 4 boxes high and 7 boxes wide, then we stretched it to 8 boxes high, and we found out in the last video how many boxes wide that was. The answer was 14. But we're going to pretend we don't know the answer. So let's see if we can use a proportion to figure this out. Now, proportion questions often, well, always, let's not even use the word often. Let's be really clear. Proportion questions that can be solved using proportions, have certain characteristics. And if I know what they are, and I can notice them in a problem, then I know when a proportion is the right way to solve the problem. So this problem is a problem that can be solved with proportions. I'll tell you the problem again. Here's the problem. I have a picture of an AMC Pacer, also known as the fishbowl on wheels. It has a height of 4 boxes and a width of 7 boxes. I'm counting boxes as being these boxes, the grid, like the graph paper grid on the screen. I want to stretch and increase the size of that photo. I want the height, instead of being 4, I want to change it to a height of 8. And if I change the height to 8, then what will be the length? This is the original drawing, 4 by 7. I want to find the stretched or enlarged drawing, which will be 8 by some mystery number. Okay, so here are the things that the characteristics of a proportion question. The first characteristic of a proportion question is that we have two situations. Right up here in red, we have the original picture. I'm going to call that situation A. But we also have a second situation, and that's what I'm showing in green here. We also have situation B. Situation A said, well, here's the original drawing of the car. Situation B says, well, here's the stretched or the enlarged image of the car. So that's the first characteristic that we look for to know if a problem can be solved using proportions. Does it have two situations? But there has to be more than that. Has to be more than that. Here's the second thing that we look for. It has to be a situation A, and situation A must have a ratio. Well, that makes sense, doesn't it? Because we know that proportions are built out of ratios. So if a question has ratios in it, it's likely we can solve it using proportions because proportions use ratios. So situation A here does have a ratio. It has a ratio of height compared to width of 4 to 7. And situation 2 also has a ratio. Same thing, we're comparing the same things. Remember, a ratio is a comparison of two or more things. In situation A, we're comparing height to width. In situation B, we're also comparing height to width, but we have a different situation. Situation B is comparing a height of 8 compared to, we don't know and we want to find out how much is the width in situation B. So questions that can be solved by proportions have these characteristics. Two different situations, and each situation will have a ratio. The ratio will be comparing two things in situation A. We'll be comparing the same two things in situation B, but the numbers that we're comparing in ratio of situation A will be different than the numbers we're comparing in the situation B, and often, well, always, in one of these two ratios, something will be missing. In this case, it's this, and we'll be able to find it. Let me show you how we can find the missing thing now. So this is the ratio from situation A. This is the ratio from situation B. Let's bring those ratios forward and work with them. So ratio from situation A, we're going to continue to use red for situation A. So I'm going to pick up the red marker, and the situation A was comparing height to width. I like to write this down first because it reminds me of the order that I'm using in the ratios. I'm using a comparison of a height of 4 compared to a width of 7. And remember that situation B, well, I chose to use green for that. If you want to use different colors to help them stay apart, then that's great too. 8 compared to I don't know. And this becomes it's not a proportion yet. I sure have two ratios. The minute I put an equal sign there to say, well, those things are actually equal, they're proportional to each other, now I've got a proportion. Now, how do we solve this thing? Well, some of us like to put the letter N here instead of a question mark. N, I could put any number, any letter there, not any number. No, there can only be one proper number answer to this. But I use letters in math to remind me about the things I don't know. So I'm going to say here that this thing I don't know is letter N is standing for that. N stands for number. It could stand for number, it could stand for anything. So to solve this problem, I can use algebra. And the algebra will lead me to notice that there's always a certain pattern to how I solve these things. So I'm going to show you the pattern. If you want to show to know the algebra, we can talk about that another time. But the pattern to solving these things is look for the diagonal that's got two numbers on it. Look for the diagonal. So this diagonal's got a 7 and an 8. Going diagonal meaning bottom of one ratio compared to the, or matching, or not matching, bottom of one ratio and the top of another. This diagonal has not got two numbers. It will soon. As soon as we find out what n is, we'll have two numbers. But right now it's just got one number and a letter. This is the diagonal that's got two numbers. So the first step to solving this proportion, and when I say solving this proportion, we mean being able to figure out what the missing number is. I start by taking 8 times 7. I multiply the two numbers on the diagonal. That will give me 56. That's step 1. And then step 2 is to take that answer that I just figured out and divide it by the number that we haven't used yet. This is the number we haven't used yet. So I'm going to divide that by 4. And what do I get? 56 divided by 4 gives me an answer of 14. So that means that this thing that I was wondering about, I now know that that stands for 14. So I can write this whole proportion now with everything that I know. The original diagram was a comparison of height to width of 4 to 7. Now, the enlarged image is a ratio of 8 to 14, and those are equal. The diagram remained proportional. It didn't look overstretched or shrunk. This 14 now is the answer to our problem. So this is how I solve problems using proportions. And what we learned back here are some of the characteristics of problems that can be solved by proportions. They will have two situations, and each situation will have a ratio, and in the ratios we're comparing the same things but with different numbers. All right.